cavity. The question now is, what produces it? The ciliary body. So the ciliary body, see this white there? The ciliary body produces the aqueous humor. Specifically, the ciliary processes. See these little ridges here? Not the grooves in between, but the actual ridges. All these little ridges, little red ridges, are ciliary processes. They produce the aqueous humor. It fills the front of the eye. Now see those little, let's see those little dots here? There in the sclera, and there in the sclera, they're holes. That's actually a little vein called the sclerovenous sinus. So the point is, those ciliary processes produce aqueous humor 24/7, going into the front of the eye, going into the front of the eye. If all they did was fill the front of the eye and never ever drain out the eye, the pressure in front of the eye would become horrendous. So the role of the sclerovenous sinus there, in the anterior part of the sclera, is to drain out the aqueous humor. So new enters, old drains out. New enters, old drains out. Drains out into these, back into the veins again, back into the venous circulation, constantly being recycled. And by the way, you may have heard of glaucoma. Glaucoma is a disease of the sclerovenous sinus, so it doesn't drain properly anymore. So aqueous humor pressure builds up, builds up, builds up, pushes against the lens, pushes against the vitreous humor, which pushes against the retina, and starts damaging rods and cones, and you go blind from all that pressure buildup up against the retina in the back of the eye. Okay, let's see, what else can we point to? So we have choroid, ciliary body, iris. Ciliary body includes those ciliary processes, but it also includes ciliary muscles. See this thick area of red that continues all the way across there, forms a donut shape. So you've got a donut-shaped smooth muscle called the ciliary muscle. What does it attach to? The lens. It also attaches to these suspensory ligaments. Actually, the muscle attaches to these white suspensory ligaments. The ligaments attach to the lens. So the muscle contracts and relaxes. The lens changes shape. It flattens and bulges, flattens and bulges. When it bulges, it bends light at a steeper angle. When it flattens, it reflects light at a flatter angle. And so that affects image formation. Unit 3 will get into the role of lens shape in forming an image close up versus far away. Let's see what else do we have? This is not a good one for the macula lutea and the central fovea. However, this does show you the blind spot I was talking about earlier. There it is, right there. There's the blind spot. The blind spot is an area of the retina with no rods or cones, but this is where the optic nerve is. The optic nerve is leaving the back of the eye. There's another name for the blind spot. Anybody know what that is? It should be in your book. Blind spot, aka optic something or other. Blind spot, also known as the optic disc. Can you find a page showing the term optic disc, possibly? I know one of those pages does. I've taught this lab often enough to know that. I can't remember what page number it is, though. The blind spot, aka optic disc. Here's the point, guys. Don't worry. Okay, we're getting distracted now. Don't need to really find the exact page number. This is the blind spot for optic disc. The point again is no rods or cones, so no light sensitivity here. Here's another important thing to know. Immediately lateral to the blind spot, again, this model doesn't show it, is where we have a structure called the central fovea. That's a high density of cone cells, just cone cells. As we move away any direction from the central fovea, cone cell numbers gradually decline, rod cell numbers gradually increase. So as we get farther and farther out from that central fovea, fewer and fewer cones, more and more rods. So come all the way to the anterior edge of the retina, right there. What do we call the anterior edge of the retina? The ora serrata. And this is peripheral vision. We use this part of the retina for peripheral vision, and it's mostly rod cells there. So we mainly use rod cells in peripheral vision. We mainly use cone cells for straight ahead, direct